Okay, P.1 Day 3. We're still talking about algebraic expressions, mathematical models, and real numbers. So for this part of the lesson, our objectives are we're going to use inequality symbols, we're going to evaluate absolute value, and we're going to use absolute value to express distance. So we start out talking about the real number line. And so the real number line is a graph used to represent the set of real numbers. An arbitrary point called the origin is labeled 0. The distance from 0 to 1 is called the unit distance. And hopefully that makes sense because from 0 to 1 it is 1 unit, so this would be the unit distance. Numbers to the right of the origin are positive. And numbers to the left of the origin are negative. On the real number line, the real numbers increase from left to right. And so you can see the picture there showing you the number line, shows you the negative numbers, the positive numbers. It's the same number line that you used to learn back when you were in elementary. All right, so inequality symbols. The following symbols are called inequality symbols. These symbols always point to the lesser of the two real numbers when the inequality statement is true. So remember, it's like a little alligator mouth. It's going to eat the bigger number, okay? So this says A is less than B. Remember, if they add the little line underneath it, that means or equal to. So this reads A is less than or equal to B. A is greater than B. And A is greater than or equal to B. Another way to remember that this is less than is that looks like a lazy L, you know, L for less than. It just won't stand up, okay? All right, so when we compare the size of real numbers, we say that we are ordering the real numbers. Oops, sorry about that line. All right, the absolute value of a real number A is denoted with those bars with the A inside of it. And so we can see it's denoted like that. That's what it's going to look like. Remember, those two bars mean absolute value. And remember, absolute value is a distance from 0 to a number on the number line, okay? So the absolute value is the distance that a number is from 0. Distance is never negative, okay? So it said it's always going to be non-negative. So it's never negative. It's always going to be either 0 or it's going to be positive. All right, the definition of absolute value reads like this. And so let's talk about that for just a minute here. So we have our absolute value of A. It says if that A that's inside is a positive number, then it's just going to be equal to A. If the A inside is a negative number, then it's going to be equal to negative A. And so what that's saying is, let's look at an example before we look at the next slide. If I have the absolute value of 5, well, we know 5 is how many units from 0? 5 units, right? So that would be our absolute value. Then here it says, what if I have the absolute value of negative 5? Well, how far is negative 5 from 0? Well, it's still 5 units. It's just going to the left this time. Okay, so the absolute value of negative 5 would also be 5. But by definition, what they're saying here then is that to find that absolute value, you're going to take, because negative 5 inside here is a negative number, you're going to take the negative of it. Okay, and a negative 5 is that positive 5. So it kind of seems like, why do we have to do that when we're looking at just the numbers? And that's going to show up on the next slide here, okay? Oops, sorry about that. All right, so it says, let's rewrite the expression without absolute value bars. Notice, the one I gave you, we had an integer, right? We had 5 and we had negative 5. Those are integers. We were able to come out with an exact answer. On both of these examples, we have an irrational number. Remember, an irrational number is a number that just keeps going. It never, ever ends. It can't be made into a fraction. And so, therefore, we can't come up with an exact solution unless we leave it as that irrational number. So when we look at this here, we've got to think, okay, first, square root of 2 is approximately what number? Well, it's got to be 1 point something, because the square root of 1 is 1, and the square root of 4 is 2. And so square root of 2 has to be somewhere in between them. So it's a number between 1 and 2. So if I take 1 minus a number that's bigger than it, we're going to end up with something negative, aren't we? So we know that our number inside is negative. And if you need to, work it out. On your calculator, do 1 minus the square root of 2, and it'll tell you it's negative. Let me do that real quick for you. So 1 minus the square root of 2. It's negative 0.414, okay? So we know that what's inside is negative. By definition there, if it's negative, we're going to take the negative of what's inside. And then we just need to simplify this. So I'm going to distribute. And so I get negative 1 plus the square root of 2. And so that would be our answer. On 2, it's the same idea, except for this time it has pi in it. Well, remember, pi is approximately 3.14, right? So pi is bigger than 3. So when I do pi minus 3, this number that's in here is going to be positive. And so by definition, it says if the number inside is positive, then we're just going to take the positive of it. And you didn't have to put the little plus sign. I'm just showing you. And if you distribute the positive, then you get the same thing. All right, so let's talk about the distance between points on a real number line. If A and B are any 2 points on a real number line, then the distance between A and B is given by, you can take the absolute value of A minus B, or the absolute value of B minus A, because when you take the absolute value of them, it's going to make it equal, and therefore the order doesn't really matter. So let's find the distance between negative 4 and 5 on the real number line. And I understand they gave us the number line here, so we could actually just go ahead and count the spaces, right? But let's try it by definition. So it told me that the distance between 2 points is equal to the absolute value of A minus B, or we could have said it's the absolute value of B minus A. And so what I'm going to do is I'm going to let the negative 4 be A, and I'm going to let the 5 be a B. And let's plug it in and see. So if I'm doing the absolute value of A minus B, it's going to be the absolute value of negative 4 minus B, which is 5. So work what's inside. So the negative 4 minus 5 is negative 9. And then remember, absolute value is that distance that number is from 0. How far is negative 9 from 0? Well, it's 9 places to the left. So we come out with that the distance between A and B is equal to 9. So now let's see, does it work if I switch them because of that absolute value? So now let's take the absolute value. We said B was 5 minus, and A is a negative 4. We'll work what's inside first. Minus a negative, remember, is a plus. Still working what's inside. 5 plus 4 is 9. And then ask yourself, how far is 9 from 0? Because that's when we're taking the absolute value. 9 is 9 places from 0 to the right. And so we can see that whichever way we did it here, we ended with the same answer. Now let's prove that since we have the number line here. If I start at A, I'm going to count the spaces to get me to B. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So negative 4 to 5 is 9 spaces apart, and we were able to find that by just using this little formula here. By finding the absolute value of the distance between them, and it doesn't matter which one you do first. All right, so that was the end of day 1, but we went ahead and covered day 2 as well, so let me pull that up real quick here. I'm sorry, we did day 4 as well, excuse me. The second part of it's what I was thinking. All right, so same lesson. This time our objectives are going to be to identify properties of real numbers and simplify algebraic expressions. So this has the properties that you probably talked about back in middle school, but you don't really remember them because we don't use them a whole lot, okay? So here we have the commutative property of addition and the commutative property of multiplication. And so remember, commute means to go from one place to another. All right, so if you look at the way these are set up, I'm just going to look at the one with addition here. It has A plus B, and then they switch it to B plus A. Okay, so I think of this like we go from home to school, and then school to home. We are commuting from our house to the school, or commuting from the school to our house. Therefore, the commutative property says we're switching the order there, okay? We change the order. And you can see for multiplication, it's the same thing. The order changed. The associative property, I think about it like you associate with your friends, okay? You have different friend groups. You might have a group of friends that's like only here at school. You have a group of friends that's at home. You may have a group of friends that's in a certain sport or activity that you're in. So you have different groups of friends. And so you change your location by your groups. So your grouping changes, all right? So I remember this as I associate with my friend groups. And the big thing there is groups, okay? Because if you notice here, both of them, the addition and the multiplication one, both have A, B, C, and it doesn't change the order. But if you notice, what is grouped together changes, okay? So where at first B was grouped with A, the second part of it, B, is grouped with C. It changed groupings. You changed your friend groups, therefore it is associative. Also, let me point out while we're on this, notice there is no property for subtraction and there is no property for division. And that's only because when you're subtracting, that's the same thing as adding a negative. Because remember, plus and negative is a minus. Okay, so subtraction is covered under the properties of addition. Also, the same thing with division. We don't have a property for it because dividing is the same as multiplying by a reciprocal. Remember, reciprocal is to flip the fraction. So if we're multiplying by a reciprocal, then to divide, then that means division falls under multiplication as well. Okay, then we have our distributive property here, and y'all are usually really good with the distributive property because you know that you take whatever number with the sign included and you multiply it times everything inside the parenthesis directly next to it. Then we have the identity property of addition and multiplication. So remember, your identity is yourself, okay? So when you're looking at the identity property, what can you do that's not going to change yourself? You don't want to change your identity. Therefore, if we're adding, the only thing we can add to something that won't let it change will be 0. So what can we add that won't allow it to change? And the same thing with the multiplication, identity property of multiplication, okay? What can we multiply by that won't allow it to change? What can we multiply by that makes our identity stay the same? And when we multiply by 1, we always get the same answer. All right, so I should have put a question mark on that, sorry. What can we multiply by that will make it stay the same? And then we have our inverse properties, okay? So the inverse means the opposite. So when we're talking about addition, we're trying to say, okay, what can we do to get us back to that identity? And the same thing with multiplication, they're the inverse property of them. So what can we do that makes it come out to be that identity? All right, so with addition, we can always add the opposite. So we would add the opposite. So if it's negative, we're going to add a positive. If it's positive, we're going to add a negative. It's going to make it be 0. When it's multiplication, we're going to multiply by its inverse. Okay, remember, inverse is a flip to fraction. So if I have a, I would multiply by 1 over a. If I had 2/3, I would multiply by 3/2. Okay, it's what's going to make it equal that 1. Remember, 3/2 is the inverse of 2/3 because you have to flip the fraction. All right, so example 1 here says, state the property illustrated. First thing I notice is it's got to be something with addition because they're being added, okay? And then look at it. Did your order change? No, the order didn't change, but your grouping changed. So your friend group changed. So this is the associative property. Oops. I think I spelled that right, did I? Yeah, I think so. Of addition. All right, and then B there says state the name of that property illustrated. First thing, notice it's multiplication, okay? And they have 2 times 1 over 2. These two are inverses of each other, so this must be the inverse property of multiplication. All right, it is simplifying algebraic expressions. To simplify an algebraic expression, we combine like terms. Remember that like terms are terms that have exactly the same variable factors. So the variables have to be exactly the same. They both have to be x cubed. They both have to be y to the y to the 5th. They both have to be an xy. They have to be exactly the same variable part, and then we only add or subtract the coefficients in front of it. All right, so an algebraic expression is simplified when the parentheses have been removed and like terms have been combined. And so our last example here says to simplify this. So look here at this first part. Notice we can take that, well, actually, let me do this. Remember, you're always, when you're simplifying, you're going to use PEMDAS, okay? So we do have parentheses, but we can't combine them. They are not like terms. They don't have the same variable part. And the same thing here. We cannot combine them. They're not like terms, okay? So parentheses out. There are no exponents. Remember, multiply and divide are on the same level. But we do have some multiplication because we have this 7 times that parenthesis, and then we have this positive 2 times the second parenthesis. So let's distribute that. Let's multiply it, and I'm going to write it out. So we have 7 times 4x squared, and then 7 times a positive 3x. So it's positive 7 times 3x. And then we have positive 2 times 5x squared, so positive 2 times 5x squared. And then we have positive 2 times x. Positive 2 times x. And now let's actually go ahead and multiply. So this gives us 28x squared. This gives us positive 21x. Positive 10x squared. And positive 2x. So we've taken care of the multiply and divide. And then remember, you have add and subtract on the same level. So this is where we're going to combine our like terms. So I see I have 28x squared. I also have a 10x squared. So I'm going to write that down here. So 28x squared plus the 10x squared. I see that I have a 21x, and I also have a 2x. So the plus 21x plus the 2x. And then combine your like terms. 28x squared plus 10x squared. They're like terms, so we're going to keep our x squared, and we're going to add the coefficients. 28 plus 10 is 38. Here we have 21x plus 2x. We're going to keep the like term, and we're going to add the coefficients. 21 plus 2 is a positive 23. These two are not like terms because their x's aren't the same. One is x squared and one is just an x. So this is our solution. And that is the end of P.1.